All right, let's jump right in. Today, we're going to get under the hood of our digital world and really demystify the basic ideas behind computer programming. And don't worry, this is for everybody, even if you've never, ever written a line of code in your life.
So let's start with the big one, right? Why should you even bother with this stuff? I mean, we live in a world that's overflowing with apps and software, so why should you care how it's all put together?
Steve Jobs had a really powerful take on this, and it's kind of the central theme for what we're talking about today. He basically said it's not about the technical skill of coding itself. It's about teaching your brain a new, incredibly effective way to think about and solve problems.
And I mean, let's be honest, you can't get away from it, can you? Software isn't some niche thing anymore. It is the invisible engine running our modern lives. From how you order your morning coffee to the complex logistics that get a package delivered to your front door, it's all powered by code. Understanding the basics is almost like learning the fundamental grammar of the world we live in now.
And yeah, okay, there are some very practical reasons too. Let's talk money. The demand for people with these skills is just massive, and you can see that reflected in the salaries. Right out of the gate, a graduate trainee can start around £25,000. And listen, that's just where it begins. If you stick with it, get some experience, someone like a software architect who designs the entire blueprint for big systems can be earning upwards of £75,000, or even more. So yeah, it's pretty clear that knowing how to speak computer pays well. Okay, so that's the why, but what about the how? How does a simple idea in someone's head actually become a functioning piece of software on your phone? This next part is all about that core process. This is the part most people skip over, but it's maybe the most important. Before you even think about writing code, there's this whole thought process. It's super systematic. First, you have to really understand your goal, right? Let's say, I want to find the quickest way home. Then you pinpoint the actual problems, traffic jams, maybe some road closures. You look at your resources. What do you have? A map, real-time traffic data, and then finally, and this is the absolute key, you define the exact step-by-step instructions to figure out the best route. And that plan, that super detailed step-by-step set of instructions, that has a name. It's an algorithm. The absolute best way to think about it is like a recipe for a cake or a blueprint for a house. It's the detailed, no room for error plan that you create before you start mixing ingredients or hammering nails. So, if the algorithm is the recipe, then the program is what you get when you actually write that recipe down in a specific language that the computer can follow. The program is the set of instructions that takes your plan and brings it to life. And that's the perfect lead-in to our next question. What are these languages? If a program is written in a language, what does that even mean? How do we actually talk to a machine? The best way to wrap your head around this is to compare it to something we all know, human language. Just like English has grammar, programming languages have something called syntax. They have their own vocabulary of special keywords. And just like you might translate from English to Spanish, a computer has to translate the programming language into its own native tongue. And that translation part, that's called compilation, and it's absolutely critical. See, a programmer writes in a language like Java, which is readable to us. But the computer's brain, its processor, only understands one thing, a long stream of zeros and ones. That's it. Compilation is the magic that bridges that massive gap. And just like a mechanic doesn't have just one wrench, programmers have a whole toolbox of different languages for different jobs. For building websites, languages like Java and PHP are really popular. If you're working with huge amounts of data, you'll probably use SQL. And for heavy-duty science or engineering work, you've got specialized tools like MATLAB or Fortran. All right, let's do a little rapid-fire round here. To really get this stuff, you've got to know a few of the essential terms, the real building blocks of all this. First, source code. It's exactly what it sounds like. It's the actual text, the raw instructions that a programmer types into a file. Think of it as the raw ingredient of any software. Next up, variables. This one is so important. A variable is it's like a labeled box. That's it. A box where you can put a piece of information, like a number or a name. You might have a box labeled current score or player name. And the cool thing is, the value inside that box can change while the program is running. Now, we touched on this, but it's so important we have to say it again. Syntax.
Think of it as grammar but on steroids. It's the super strict, totally unforgiving set of rules for a programming language. You know how if you text a friend with a typo, they can still figure out what you mean? A computer can't. You miss one comma and the whole thing just stops. It won't understand. And because syntax is so unforgiving, making mistakes, what programmers call bugs, is just part of the game. It happens to everyone. So the process of hunting down those errors and fixing them is called debugging. And calling it detective work for code is the perfect description. It takes a lot of patience and a really sharp eye. Okay, so we've got the why, we've got the core logic, we've got the lingo. Now let's tie it all together and see what this actually looks like in practice. Let's take a real-world example, a hugely popular language called Java. It showed up back in 1995, and its killer feature, its big promise, was write once, run anywhere. That meant you could write a program on a Windows PC, and it would just work on a Mac or a Linux machine without you having to rewrite it. It was a game changer, and today it's an absolute powerhouse, especially for web stuff.
And listen, programmers aren't just typing this stuff into a plain old notepad. They use these powerful tools called IDEs, and a great one is named Eclipse. The best way to think about an IDE is like Microsoft Word, but for code. It helps you write everything, it checks for syntax errors, it helps you organize your project, and it even has tools to help you debug, all in one place. All right, let's put it all together one last time. Let's walk through the entire journey from start to finish. Step 1, it always starts with a problem you want to solve. Step 2, you design the algorithm, your master blueprint. Step 3, you write that blueprint down as a program using source code. Step 4, that code gets compiled into the zeros and ones that computer understands. And step 5, you run it and, yep, you start debugging. That is the fundamental loop of how software gets made. And that whole process, it brings us right back to where we started, to that big idea. We've just unpacked the language of technology. But it makes you wonder, doesn't it? What are the other essential languages out there that we need to learn to really understand our world? Is there a hidden logic to economics? A repeatable pattern in art or in our social systems? It's definitely something to think about.